And on behalf of TIM Brasil, I'd like to thank you the opportunity to be here. And so, what is the, okay. And it's not all about throughput anymore, as we're discussing during this day. 5G technology is designed to really change the way we interact with the world. Of course, we will have vertical that provides extreme high data rate communications, the enhanced mobile broadband. But more than that, there are also two other 5G use cases rise, that is ultra reliable and low latency communications for network services with extreme requirements on latency and reliability, like V2X communications and Industry 4.0, and massive IoT too. Scalable connectivity for increasing number of devices, efficient transmissions of small payloads, wide area coverage, and deep penetration. So the key point is that services will drive 5G architecture development and deployment, which means that in 5G, we must create services to create network after, okay? And the target is to support a wide range of service types, each associated with different business models and its requirements. So, starting from technologies that are already implementable in LTE and its advances, 5G system is a service-based architecture. We are moving on to a service-based architecture that shall facilitate the diversity to a reasonable cost, okay, and by a cloud-native infrastructure and advanced network slicing techniques and core network, okay, and in radio access network perspective, new spectrum bands like millimeter waves, as we discussed it today, and mid bands, 3.5 gigahertz, the application of models of sharing and combine it to the new radio with active antennas, massive MIMO techniques, and a flexible 5G frame structure. All of this will enable 5G to be everything as a service. Okay, and here's the 3GPP roadmap too. But if can I talk quickly about the key points in the last slide, I'd like to say spectrum is the main asset for a mobile operator, and new spectrum is crucial for the success of 5G. We must take into account that all spectrum bands are relevant for 5G because all of them has his importance depending on the use cases and its requirements. It's a trade-off between coverage and capacity. The ITU our roadmap for harmonization and standard and identified for IMT spectrum bands. And there are various efforts around the world underway to find harmonization spectrum, okay? And there are 11 bands in millimeter waves under study, but we know that not all of them will be identified for IMT. Regarding to architecture, most practical 5G deployment options are 2 for standalone and 3 and its variants for non-standalone deployments. And their coexistence will be required as user equipment with pre-release 15 NAS will stay in the network for many years. So progressively upgrading eNodePs piece to ELTE towards to 5G core and progressively deploying standalone non-radio we will introduce options 4, 5, and 7. And moreover, in release 15, 3GPP standardized the functional split between central unit and distributed unit for 5G, 5RAN for 5G. That has a main goal, enabling access feature coordination between different 5G sites to achieve cluster performance enhancement. And concerning 5G RAN, new radio is also designed to be very flexible to accommodate the different use cases, and different numerologies can be used in the same frame structure. Okay, the frame duration is set to 10 milliseconds to ensure coexistence with LTE as well, but symbol and slow length will scale with the subcarrier spacing. And this is the main point to ensure all the different use cases in different 5G verticals. And there is challenges posed by TDD spectrum. We know that new radio above 3 gigahertz is defined as TDD only, but like in network synchronization, and intra and inter-operator, or mobility in high bands that is susceptible of fast fading, or uplink coverage. But there are also efforts to mitigate these issues, like supplementary uplink to improve uplink coverage. And massive MIMO and bin management is also an important and relevant aspect in 5G RAN. Okay, all of the current TDD massive MIMO implementations rely on TDD. So this is an important thing too. And finally, regarding 5G core, here is a 5G system core architecture in reference point representation, but we know 5G is a service-based architecture, so the EPC will evolve with control and user plane separation, and then the network elements will evolve to an independent, modularized, and scaling functions in an on-demand orchestration. Once network function, each one of network function could directly interacts with another network function. And NFV is native in 5G technology. And these are the key messages that TIM bring for this meeting. And we think that this allows 5G to support various services and to enable flexible and efficient network slicing. Okay, thank you very much for the opportunity.